Okay, everybody, try to stay patient with this one, especially if you found the structure of the atom video and concept to be challenging, because this is more of the same. So be patient. Remember, you can watch the video as often as you like. And the final time you watch the video tonight, before you put it away, please remember to make a list of questions of things that are still bothering you or things you still don't understand, so that you can be sure to ask me when you see me in class tomorrow. Let's get started. This is a revision of the previous video and therefore your previous lesson. You can choose for yourself whether or not you copy down the contents of this particular slide. Once we move on to the new material, though, that's what I will be checking is definitely in your book. So, as a revision, please remember that atoms are made of three smaller particles. Protons, which are positive, and neutrons, which are neutral, are found together, lumped up to build the nucleus, the two of them together, and that's found at the very center of the atom. Also, the third type of subatomic particle is called electrons, and those are negative. They are found in shells around the nucleus. Remember that an atom must be neutral. Therefore, because the protons have a +1 charge and the electrons have a -1 charge, to make the atom neutral, protons and electrons must be the same number. Remember that the electron shells must fill from the inside out. And finally, that electron shells can only fit a certain number of electrons before they're full. So let's move on to ions. That's the real purpose of this video. What's an ion? An ion is a charged particle that forms when an atom gains electrons or loses electrons. Ions can be positive or negative. How do they form? Well, importantly, atoms hate when their outermost shells are only partly filled. They'll do anything to fill up that outermost shell. Therefore, some atoms will steal electrons from their neighbors in order to fill their own outer shell. Some electrons will give electrons away to their neighbors in order to fill up that shell. Atoms of metal elements will tend to give the electrons away, where atoms of non-metal elements will tend to steal the electrons from their neighbors. But why would they do that? Let's have a look at sodium atoms as an example. How do sodium atoms form ions? All right, let's start from the very beginning again. Sodium is a metal. Sodium is element number 11 on the periodic table. If you'd like, you can pause and prove that to yourself by looking at your periodic table. That means that sodium must have 11 protons in its nucleus. Therefore, in order to make a sodium atom neutral, it has to also have 11 electrons. That means that the electron configuration of the sodium atom is 2, 8, 1. That means that a sodium atom has 2 electrons in its first shell, 8 electrons in its second shell, and 1 electron all by itself in the third outermost shell. Now remember that sodium wants its outer shell to be full. In order to do that, it could steal 7 electrons from other places, or it could give away that single 11th electron. So that's what it does. When it gives away that outermost electron, that single electron all by itself, that third shell becomes empty, and the outermost shell becomes the second shell, which is full. Now, though, there are only 10 electrons, 2 in the first shell and 8 in the second shell. But there are still 11 protons in the nucleus. The nucleus is unchanged. That means a sodium ion has formed because it has more positive charges than it has negative charges. So overall, it's a charged particle. The electron configuration of our sodium ion is now 2,8. And that would be a diagram. That's another diagram that you should copy into your book. So that's only one example, and you're going to do many, many more before this is done. But for tonight, there's only one more thing I want to draw your attention to, and that is the symbol of the sodium ion. So, when sodium was an atom, its chemical symbol looked like this. Capital N, lowercase a, and that was it. Now that it's an ion, we need to show that the ion is different from the atom. So we have to write its chemical symbol like this. That's a capital N, a lowercase a, and then in a superscript up above the line, crowded nice and close to the A, is a positive sign to show that this sodium particle is an ion that has a positive charge. That means that there is one extra proton compared to the electrons. And that's what you need to know for tonight. Remember, you can keep watching this video until it's answered your questions. And if you still can't get your questions answered, jot them down and we'll discuss them in class tomorrow when you're practicing with more problems.